Hello and welcome to Data Religion's BigQuery ETL Foundation video 2. We are working with unstructured data. If you have watched the previous video, you saw how we created a table with unstructured DateTime format, extracted date and time from it, and parsed date and time. In this video, you are going to learn reconstructing DateTime from the date and time created in video 1, converting the DateTime to timestamp, and understanding time zones in timestamp, because if you don't understand the concept of how time zones apply to timestamps, then your BigQuery derivations can seriously go wrong. Let's get started. We are on the BigQuery Explorer interface and we are looking at the CakeShop 2 table that we have created in our previous video 1. If you haven't watched that video, please watch, because video 2 is absolutely linked to video 1. So we are looking at CakeShop 2 table that we had created from CakeShop table using a query. And in this table, we have two new columns added, parsed date, parsed time, which are in proper date and time format. So the first task that we are going to do in this video is relatively easy. We are going to reconstruct the date time format and then we will write the whole operations into a new table, which will complete our first basic ETL job. Then we will take a queue from there and we will explore the timestamp options on the date and times that we have derived so far. So let me go to that table. So here we are on CakeShop 2 table, and let me run a query to recreate date time from the parsed date and parsed time. Before we do that, let's go back to the CakeShop table and have a look at how the date time column was. So the delivery time was supposed to be a date time column, but its input was in string format. Let us have a look at the table, and you could see that it was completely unstructured. The dates were totally unstructured, and from there we have derived in the previous table the correct date format and the correct time format. Now we are going to recreate the date time format and write that into a new table. Let's run the query in a new tab. Select star, then we will invoke the DateTime function, DateTime, parse date, parse time, we will just select here, parsed dt. So this is a simple function, DateTime function, that parses the DateTime format from parsed date and parsed time columns that we have created in the previous table. We are able to do it so easily because both these columns, parsed date and parsed time, are in proper date and time formats. Had they been in string formats, we had to first cast them into date and time formats respectively and then run the DateTime format. So let's run the query. Okay, so these item delivery time were the parts of the previous table. Parsed date and parsed time we created in CakeShop 2 table, and parsed dt is the new value that we generated, which is in proper date time form. What is the difference? See the T here. Date and time is generally separated by a capital T, which we didn't have in the previous delivery time column. So I would be slightly more accurate here. Let me just write delivery time and let's run. So suppose your task is to recreate the old table in proper format, like the CakeShop table had wrong date time structure. So your task is to recreate that table with proper structure. So what are we going to do? We have to wrap another query around this query. Item, this is item, and parsed delivery time from, this is it. Let's run this query. You can also give it back its own name. delivery time. Run the query. Okay. So if I now write these results into a new table, you will practically recreate the CakeShop table with proper DateTime formats. So let's do that. Create table etl. ETL is my dataset here. ETL CakeShop 3. Give the backclicks. You can see BigQuery is saying this query is valid. So create table, we are creating CakeShop 3 table. So what would have happened if I wrote this? Create or replace table and just CakeShop. Yes, you are right. It would have replaced the CakeShop table. But we are going to require this unstructured table a few times more. So I'm keeping it there. So I'm not replacing this table. So let's create it as CakeShop 3. Let me remove the replace part. No harm if I keep it here, but let me remove. Cool. Let me run the query. Okay, my query has run and the statement created a new table named CakeShop 3. So let's have a look at CakeShop 3. You can see that item is string and delivery time is created in proper DateTime form. Let's go to the preview of it. At the same time, let's compare it with the CakeShop table that we created in video 1 and see the delivery time was passed to it as a string and the dates were totally unstructured. But if I go to CakeShop 3, the dates are properly structured, times are structured, and if you go to schema, it's date time. So congratulations, you completed your first ETL task. Now let me do a quick discussion about what would have happened if instead of date time, you would have chosen to parse timestamp. I'm sure you have heard about timestamp. Now suppose your management expert boss might have told you timestamp is accepted globally and you should always go for timestamp. So let me tell you what are the challenges that you might encounter. So just write timestamp and then you already have the date time, parse delivery time as TS. Let me write CakeShop 4. Now apparently it's all fine. The timestamp formula is also resolving correct. For now, let's not create a table. So let me just deactivate these two. Let me see the results of the query. So you have your items, you have the delivery time and date and time format, and it's understood that if it's date time, it will be accepted within the time zone that you are working in. I am currently in India. So this date time is correct for India time zones. Are they correct? It's showing me the same time as the date time, but the time zone is resolving to UTC. And it's no fault of timestamp operations because timestamp always resolve to UTC. But can these two times be the same? No, no way. So what mistake we are doing here? Just by calculating the timestamp from the delivery time. So the mistake that we have done and that a lot of people do is not defining the time zone into the timestamp formula. In many cases, I have seen that people directly convert date time into timestamp, considering that it might resolve to the existing time zone. It doesn't happen that way because timestamp is an absolute value. Let's have a look at the difference between timestamp and date time. Now, timestamp is an absolute point in time that is independent of time zones, which means in your BigQuery function, you can write any time zone you want. But when the query runs, the value always resolves to UTC. So for human readability, it's generally expressed in UTC time format. Now, date time is very different. Date time is a civil representation of a combination of date and time, and it's absolutely dependent on time zone. So remember, timestamp is not dependent on time zones. It's an absolute value. But date time values might vary depending on which time zone you are in. So let me keep it this way for comparisons purpose, and let me create another timestamp value as ts1, where I can tell BigQuery we are in Indian time zone. So Asia, Calcutta. And now let me show you how the query resolves. So this was resolved when we didn't give any time zone information, and this we are resolving with the correct time zone information. What is the difference? The difference is of exactly 5 hours and 30 minutes. Look at TS1. Here the time was identified as Indian time, and then it's resolving to UTC. To resolve it to UTC, BigQuery is deducting 5 hours and 30 minutes, 330 minutes from the timestamp operations. So this is the correct value of this date time, not this one. So this one is incorrect. This is the correct value, because here we have defined the time as Indian time, and then BigQuery resolved it to UTC, and in order to resolve it to UTC, BigQuery had to deduct 330 minutes from the date time. Here is a quick tip for you. If the data model that you are working on is to be used locally and is not very complex, then stick to date time. Don't get into timestamp unnecessarily. But if it's a very high level data operation and the results of your effort will be used globally, different operations or different offices of your organization are going to use it, then resort to timestamps. Timestamp and time zone resolutions can be very challenging at some points of time. In this video, we don't have much time to explain all of that, so we will devote another full video, the next video, explaining how timestamp is resolved from various date and time formats, how time zones are applied. Until that time, have a great time, learn BigQuery, like my channel and press the bell icon. Thank you very much for watching.